Welcome to the video lecture 2 for the subject Introduction to Artificial Intelligence. I am Dr.M.Hemalatha, Professor, CSE Department, RMDEC Engineering College. Topic of this video lecture is AI problems. Before getting deep into this, first let us list out the example problems that are stated throughout this course. Maze problem, puzzle problem, chess game, 8 puzzle problem, path finding problem, traveling salesman problem, TSP in short, robot navigation, block world problem. Problems. For AI problems, first we should know a clear idea about the problem. It has to be formulated properly. When we formulate, we should know what is going to be our goal. So in most of the problems, goal will be given. The goal will be to process or the process of deciding what actions and states to be considered. For me to solve AI problems, ultimately we will be doing search operations. We will be searching and executing step by step towards the required goal. And the generic method used for search process is termed as heuristics. And for all this process to work properly, the problem has to be well formulated. So now comes, what is a well formulated problem? A problem is said to be well formulated if it has 4 components. A clear statement of initial state, successor function, goal test and path cast. Initial state refers to the starting condition, otherwise stated as problem configuration. Successor function is set of possible actions or resulting states from a given state. Goal test is the condition, in some cases the function, that determines whether we have reached a goal state or not. Goal state can also be stated as problem's goal criteria. Path cost is a numerical value. It is a cumulative cost. It is the cost of sequences that are adapted from initial state to the final state, goal state. In nutshell, what is a well-formulated AI problem? Initial state is defined as the starting point of the problem-solving process. Successor function generates possible next states from the current state. Goal test checks if a state meets the problem's goal. Path cost is the total cost of actions leading to a goal state. To give an example, agent initial position in a maze. In the maze problem, agent's initial position is called as initial state. Moving in different directions in a grid-based environment, every move can be called as a successor function. Verifying if the agent has reached the maze exit, that determines the goal test. And summing the entire traveled path cost is called as path cost. So for us to solve AI problems, what has to be done? 2 things has to be done. One is choose, second one is analyze. We have to choose the most appropriate method. It could be a single method or combination of methods. Once you have chosen an appropriate method, you have to analyze the problem along different dimensions. So the key dimensions are stated down, and every dimension can be put forth as a question. Is the problem decomposable? Can solution steps be ignored? Is the problem universally predictable? Is a good solution to the problem obvious without comparison to all other possible solutions. Is the desired solution a state of the world, or is it a path to a state? What is the role of the knowledge? Does the task require interactions with the persons? We will see each topic in detail. The first one is a problem decomposable into set of independent smaller subproblems. Technically speaking, solving a problem by decomposing it into set of independent smaller subproblems is called as divide and conquer technique. We break down the given problem into smaller subproblems. Each subproblem will be simpler to solve. Each subproblem can be handed over to different processor. Hence, it can be solved in parallel processing environment. Please note, there are few problems which cannot be decomposed. One example is this goal state problem, blocks world problem. And example for divide and conquer technique problems which can be solved by decomposing is an integration problem where you can subdivide into smaller parts, get solutions for smaller parts, club all the solutions, you will get the solution for the original problem. A second thing is, can solution steps be ignored, or at least can it be undone if they prove to be unwise? So what decides the answer for these questions? Based on the answers for these questions, we have to know types of problems. A problem can be of three things. It can fall into any of these buckets: ignorable problems, recoverable problems, irrecoverable problems. Ignorable problems, they can be solved using simple control structures that never backtracks. Recoverable problems means it can be solved by a slightly more complicated control strategy, but it allows backtracking. Irrecoverable problems means it will need to be solved by a system that expands a great deal of information in making each decision, because since decision will be made final and taking decision is very important. The third aspect is the problem's universe predictable. Based on the universe predictability, you can classify all problems into two broader ones: certain outcome problems, uncertain outcome problems. Certain outcome problems guarantee a solution, whereas this one does not guarantee a solution. In certain outcome problems, sequence of operators will lead to a solution, whereas here the sequence of operators has a good probability of leading to a solution. And in the first type, certain outcome problems, planning avoids unwanted solution steps. Here, it's going to be very expensive because solution paths to be explored, the paths that has to be explored increases exponentially. So, finding or planning for the entire lot is going to become very difficult. Example problems which comes under certain outcome problems category are 8 puzzle problem and water jug problem. Examples for uncertain outcome problems are playing cards. The fourth aspect of solving a problem is asking the question, is a good solution to a problem obvious without comparison to all other possible solutions? Based on that, we can categorize them into two. Is there any, it can be called as any path problem or best path problem. Any path problems, here any path that satisfies with the solution is considered. In best path, not just any solution is acceptable. You are concerned about finding the best solution. In any path problem, the solution path taken, you need not worry about the goodness or the fitness, best fitness, you don't check it out. Here, you are very keen of getting the best path. In any path problem, we obtain a solution by heuristics methods. We do not explore alternatives. In best path problems, the problem to be solved has to be solved in a reasonable amount of time. You'll be using heuristics. Good paths has to be explored. All possible paths are explored, hence it becomes an exhaustive search and it becomes computationally harder due to this exhaustive search. Example for any path problem, again water jug problem and 8 puzzle problem. For best path problem, it is TSP, traveling salesman problem. The next aspect is the desired solution a state of the world or a path to a state? What is this statement telling us? I have a problem. I need to solve it. I need to find a solution for this problem. But when I want to find a solution, I have to be very clear what is to be considered as a solution. Is the state my solution or is the path to a state is my solution? In the first category, your NLP, natural language processing, finds its place. We need to find the interpretation. Here, the record of processing by which the interpretation is found is is important. Here, the solution is just one state. I want to reach that state. Whereas here in certain problems, the path to a state is important. If we take water jug problem, solution is alone not sufficient. The path for the solution is very important because there might be multiple solutions and some cases we opt for the optimal solution. So here reaching the goal state, rather than reaching the goal state, the sequence of operations that are performed to reach the goal state is very important. Our next aspect is what is the role of knowledge? I have a problem. We need to find a solution for the problem. For finding a solution, to make it much better, we exploit computer power. The enhanced AI systems now has the capability or availability of knowledge base and hence it is helping us to solve problems very quickly. Now, what is this KB, knowledge base availability, going to do its part? I can have small KB or it could be large KB. When is small KB okay? For game of playing chess, where for problems like this, where the rules for determining legal moves and some simple control mechanisms is sufficient for me to reach a solution. But there are some cases, say like predicting the political trend, right? Here you want enormous amount of knowledge and it is going to take lot of resources for it. So you have to decide what is the role of the knowledge for your problem and based on that can we reach the solution for the problem. Does the task require interaction with the person? This is the next aspect. Should it be a solitary one or is it going to be a conversational one? Solitary means, example could be theorem proving, where you will have basic rules and laws and you will be able to prove it if something like that exists. So you are given a problem description, you feed it to the system will give you an answer. But there is other category which is called as conversational, where there is a need for the human to play a role in finding out the answer from the given problem description. With this, we end our video lecture 2. Thank you.